Hi, so this part of video lecture is on the topic of laws of motion, and we continue with friction, and this time we'll take block placed on fixed inclined plane. So what is this method we follow to solve the questions related to block placed on fixed inclined plane? This is typical sequence of steps. First, we choose coordinate axis, and we should choose x axis along the slope so that acceleration in y direction is equal to 0. Then we draw the free body diagram, which basically involves resolving mg. We'll mark all the forces except friction force, as its magnitude will depend on other forces. Then after drawing the free body diagram, we find the value of normal reaction using equation summation of force in y direction has to be equal to 0. And once we have the value of normal reaction, we can find out maximum possible friction force F max, which will be equal to coefficient of static friction into normal reaction. Finally, we'll compare the forces, summation of force in x direction. For purpose of this lecture, we'll call summation of force in x direction as driving force, the force which is trying to slide or move the block, and we'll compare this Fx with maximum possible frictional force, that's a resisting force. And when we compare these two values, we can find out the state of friction, which could be static, limiting, or kinetic. So if you look at this, what is the aim of these 4 steps we have? To find if the object will move or not. Now, once we figure out by comparing the driving force, which is trying to move, with the maximum resisting force, which is maximum frictional force. Now, once we find out whether the block is once we find out the state of motion, it becomes much easier to solve the question. So let's take a simplest example. The block is placed on inclined plane. There's no external force acting. So only force acting is the gravitational force and the contact forces. So this is the free body diagram here. If we resolve mg into 2 components, this angle will be theta. So the normal component of mg is mg cos theta, and the component along x axis will be mg sin theta. This is the normal reaction. So from free body diagram, we can easily find out the driving force is mg sin theta. That's the force which is trying to slide the block down the slope. And maximum frictional force will be equal to mu times normal reaction, and the normal reaction here is equal to mg cos theta. So maximum friction force is coefficient of static friction into mg cos theta. So we can find out the state of motion by comparing driving force with resisting force. So there are 3 possible cases. One possible case is Fx is equal to F max, which is the limiting state. Both are equal. So Fx is equal to mg sin theta, and maximum friction force is mu s into mg cos theta. In other words, tangent of theta will be equal to coefficient of static friction when both are equal. This is a limiting state. In limiting state, the value of acceleration is still 0, and hence the friction force will be equal and opposite to driving force, which is mg sin theta, and direction of friction force will be in the upward direction. So when angle theta, tangent of theta is equal to mu s, or we call this angle as critical angle. So tangent of theta c is equal to coefficient of static friction, is a limiting state, acceleration is 0, and friction force is equal to maximum friction force. So if we increase this angle of inclination slightly from the critical angle, it will go into a static state. The block will be in a state of rest. And if we increase the angle theta a little bit more than the angle given here, it will go into kinetic state, which means the block will start sliding down, which makes common sense. If the angle of inclination is higher, the block will tend to slide down. If angle of inclination is lower, the block will tend to remain at rest. And what is the angle which decides, which is the borderline between 2 states, is critical angle. Tangent of critical angle is equal to coefficient of static friction. And this angle is called angle of repose. So let's look at the second possibility. The case B could be when the driving force is smaller than maximum frictional force. Naturally, this would be static state. The driving force is not adequate to make the block move. So in mg sin theta is less than mu s into mg cos theta, or tangent of angle is smaller than coefficient of static friction. In case of static state, A is equal to 0, and hence friction force will be equal and opposite to driving force, which is equal to mg sin theta. So friction force will act up the slope and magnitude is equal to mg sin theta. So angle tangent theta, when it is less than mu s, static state, F is equal to mg sin theta, which is less than maximum friction force. Third possible state, when driving force is greater than maximum frictional force, kinetic state. Mg sin theta greater than mu s into mg cos theta, or tangent of theta is greater than coefficient of static friction. So angle is large enough that driving force is greater than maximum friction force and block will move. So in kinetic state, the friction will be kinetic friction, which is equal to mu k times the normal reaction. Coefficient of kinetic friction into normal reaction mg cos theta. And in kinetic state, the acceleration value will be equal to net force divided by mass. Net force will be equal to mg sin theta down the slope and kinetic friction up the slope. So net force will be equal to mg sin theta minus mu k mg cos theta, and we divide by m, we find the value of acceleration equal to g into sin theta minus mu k cos theta. Thus the acceleration in case of kinetic state when theta is greater than mu s. What is the condition? Tan theta greater than mu s is kinetic state. Friction is equal to Fk, kinetic friction, and acceleration is equal to g into sin theta minus mu k cos theta. Now we'll have some conceptual questions. These are fairly easy questions. We suggest you follow a sequence of 4 steps. After reading the question, pause the video, solve the question, restart the video and check your answer. You might like to repeat this sequence for all of the conceptual questions which follow. First one, a simple question, a block M of 10 kg is initially at rest. What would be the state of friction if theta is gradually increased 30 degree, 37 degree and third case 53 degree. So again, you might like to follow the 4 steps. So let's look at how do we analyze this question. This is standard case of only gravity acting and the block is initially at rest. The state of friction will only depend on the how this angle theta compares with the critical angle. So state of motion or state of friction will depend on comparison of slope with the critical angle. What is the critical angle? Tangent of critical angle is equal to coefficient of static friction, which is equal to 3 by 4 here. So critical angle is 37 degree. So at 37 degree, it is in the critical state. And if theta is less than critical angle, it is static state. Angle too small to cause slipping. And in this case, friction force will be static friction equal to mg sin theta. In this particular case, mg sin theta at angle of 30 degree comes to 50 Newton, which is less than maximum possible friction force. So first case, when theta is equal to 30 degree, it is static state, friction is equal to 50 Newton, less than maximum friction force. So we'll continue the second one. Again, since the value of mu k and mu s are not changing, the critical angle is same, but the angle of inclination, this theta, in this particular case is 37 degree. So critical angle is 37 degree and angle of inclination of the slope also is 37 degree. So theta is equal to theta c. It is on the limiting state or on the verge of sliding downwards. In limiting state, friction force is equal to mg sin theta as well as mu s into mg cos theta. Both are equal, which is equal to 60 Newton. So compared to the previous one, the friction force is higher at 60 Newton. Let's move to third case when the angle of inclination is 53 degree. So again, critical angle is unchanged, which is 37 degree, and actual inclination of the slope here is 53 degree. So what is state of friction? Since theta is greater than critical angle, it is kinetic state, and the block will slide downwards, or block will have downward acceleration. Friction force acting is kinetic friction, which will be coefficient of kinetic friction into normal reaction, which is mg cos theta. If you substitute these values, it comes to 36 Newton, which is less than mg sin theta. That's why there's a net unbalanced force. What with the acceleration? Acceleration is equal to g into sin theta minus mu k cos theta. which comes into 4.4 into 4.4 meter per second square. So we continue with the conceptual questions, and again to remind you, you can follow the same sequence. So what the question is, at an instance, the block M is moving down the slope at a speed v. So its instantaneous velocity is v. The question is, what would be the nature of motion? Will it accelerate, decelerate, or will have uniform motion for following values of theta? For this angle of slope, for different value of theta, what would be the nature of motion? Three possible cases, we will have evaluate each of these three cases. First case, theta is 37 degree, then what happens? When theta is 45 degree, then what happens? And theta is 30 degree, then what happens? So try to answer without use of pen. This is a fairly simple question. Hint, moment we see the block is in motion, it is nature of friction will be kinetic. And moment we say the friction force is kinetic, both magnitude and direction of friction force is known. So I can draw the free body diagram and we can solve the rest part of the question using free body diagram along x-axis. So what are the forces acting? Mg sin theta is acting downwards and kinetic friction is acting up the slope. What is the net force down the slope? Mg sin theta minus mu k cos theta. Hence, if this net force is positive, it will accelerate. If this net term is negative, it will decelerate. So accelerate if sin theta is greater than mu k cos theta. So if we compare, or other word we can say, when tan theta is greater than mu k is equal to 3 by 4. First case, what is value of tan theta? First case, when theta is 37 degree, tan theta is equal to mu k. Hence, it will have a uniform speed. Second case, when theta is equal to 45 degree. So tangent of theta will be 1, which is greater than mu k. Hence, it will accelerate. The downward force will be greater than kinetic friction. Third case, theta is equal to 30 degree. Tangent of theta will be smaller than coefficient of kinetic friction, 3 by 4. Hence, it will slow down or decelerate. It will suffer retardation. Now, we make a small change here. In this particular question, in addition to gravitational force, there is an external force acting, and the direction in which the external force is acting is along the slope, parallel to the slope. So, let us look what the question is. Mass of the block is 10 kg, is initially at rest, and force P is applied parallel to the slope. So again, first we'll take some simple questions based on this, more conceptual questions. First one is, will the magnitude of P affect the normal reaction and maximum frictional force? So if we change the magnitude of this force here, will it change the normal reaction between the block and the surface? And will it change the maximum possible frictional resistance? Think and answer. Hint, will P have any component in y direction? P is along x direction. Will it have any y component? No. Since P doesn't have any y component, hence the normal reaction will remain unchanged, equal to mg cos theta, and hence the maximum frictional force also remain constant. It will not depend on magnitude of P, and it will be equal to mu s times mg cos theta, which is 48 Newton. The maximum frictional force, as we keep changing, the magnitude of P will remain constant at 48 Newton. Now let's take a particular magnitude of P. If P is equal to 30 Newton, if the force which is acting up the slope is equal to 30 Newton, what will be the direction and magnitude of frictional force? For your convenience, we'll tell mg sin theta here is 80 Newton, and mg cos theta is equal to, mg sin theta is equal to, so mg sin theta is equal to 60 Newton and mg cos theta is equal to 80 Newton. So what will be the direction and magnitude of frictional force if P is equal to 30 Newton? Can we answer this question without any pen or pencil? What is the hint? Let's think of what is the force which is trying to move the block along the slope. Basically, we are looking at free body diagram only along x direction. There are only two forces other than friction forces. Mg sin theta 60 Newton downwards and P force 30 Newton upwards. So, what is the net force which is trying to slide the block? Net force is still 30 Newton down the slope. Hence, the friction force which is less than maximum friction force, which is 48 Newton. Since the driving force is smaller than maximum friction force, it will be in the static state and the block will not move. Friction force acting also with static friction equal to 30 Newton. So, before we move on to the next slide, just spend few minutes trying to understand the effect of change in magnitude of P. Think in your mind what will happen for various values of P. Starting from 0, as we keep increasing P, what effect it will have on the free body diagram and the motion. So, you may like to pause the video and analyze the effect of varying P on frictional force and its direction. So, let us continue looking at some more variations of the same question. Now, the third question in the series is, for what value of P will the friction force be 0? Can we figure out quickly for what value of P will the friction force will be 0? Hint, the friction force will be 0 when the driving force also is 0. So, net Fx must be 0. So, what value of P will make the net driving force along the x direction to be 0? Answer is of course 60 Newton. The net driving force will become 0 when P is equal and opposite to mg sin theta. So, when P is less than mg sin theta, the net driving force will be downwards and friction force will be acting up the slope. So, when P becomes equal to mg sin theta, net driving force becomes 0 and hence the friction force also is 0. Now, continue further, find friction force and its direction when the P becomes 90 Newton. So, we further increase the value of P, what will be the magnitude and direction of friction force? Try and think your answer. You might like to pause the video, solve and restart. Hint, think in terms of forces acting along x-axis. What are forces acting? Mg sin theta 60 Newton downward direction. P is 90 Newton up the slope. Hence, net driving force is 30 Newton up the slope. And is the net driving force smaller or larger than maximum friction force? The net driving force is smaller than maximum friction force. Hence, it would be static state. The friction force will be, acceleration is 0 and friction force will be equal and opposite to net driving force, which is 30 Newton. So, friction force acting will be static and downwards. Again, to continue this question, what should be the minimum value of P to move the block upwards? So, what has to be minimum magnitude of this force P to move the block in the upward direction? Again, pause, solve, restart, check sequence you can follow. Hint is, moment we have minimum value of P, it means we must solve for limiting state, which has two conditions. A is equal to 0 and friction force is equal to maximum value. Hence, in this particular case, friction force will be equal to 48 Newton, and since the block is on the verge of moving upwards, friction force must act in the downward direction. Friction force F max, downward direction. So, what is the FBD in x direction? Mg sin theta 60 Newtons downward direction and P is acting up the slope. Now, we can apply the condition A is equal to 0. Hence, using the FBD in x direction only, we can find the value of P has to be equal to 108 Newton, which is equal to mg sin theta plus mu s into mg cos theta. That's the minimum force we need to apply in the upward direction to make the block move. Suppose find acceleration of m if p is marginally greater than 108 Newton. So 108 Newton, it will bring it to the verge of motion. If you slightly increase the force P, it will make the block slide. It will enter into kinetic state. What will the acceleration of block M if P is marginally greater than 108 Newton? How do we solve? It's a kinetic state. So magnitude and direction of friction force is known, which is equal to Fk mu k times mg cos theta, which works out to be 40 Newton. And motion is up the slope. So how would be my free body diagram? Mg sin theta, 60 Newton acting downwards. P is up the slope, how much? 108 Newton. And friction force is kinetic friction now, 40 Newton. So what is the acceleration? Upward direction. P minus kinetic friction minus mg sin theta by m. The value comes equal to 0.8 meter per second square. Let's take a slightly different question. If a particle or a small block m is projected up the slope at a speed v. So even before we start solving the question, it's quite easy to visualize if the block is, if we give velocity by giving impulse or giving a force and some other form we are given some energy and it is moving up the slope. Naturally, it will slow down and it may come to a momentary rest. So find what is retardation, what is the maximum distance traveled before coming to stop, and third one is after coming to rest, will it slide back again, will it slide downwards or will it remain at rest? Same sequence, you can pause, solve, restart and check. First thing we notice, the block is in motion, hence the friction force acting is kinetic. We know its magnitude and direction. Kinetic friction down the slope equal to mu k times normal reaction. So if we take the free body diagram, along x-axis two forces are acting, mg sin theta down the slope and kinetic friction also down the slope. So net acceleration will be in the downward direction, we call it retardation since it is opposite to velocity, and net acceleration will be equal to g into sin theta plus mu k cos theta. So any object moving up the slope without any external force will suffer a retardation equal to g sin theta plus mu k cos theta, as long as there is no other external force other than the gravitational force. So it's simple enough. How much distance it will travel, we can easily find it out. Since the value of a is constant, I can use constant acceleration equation. So substituting in this equation, we can find the distance as it will travel before coming to stop or before the velocity becoming 0, as will come equal to v square by twice the acceleration. Acceleration is g sin theta plus mu k cos theta. That's the distance it will travel before it comes to a momentary rest. After coming to stop, the question is third part of the question. After coming to rest, will it slide down or will it continue to remain at rest? So after coming to stop, its motion, further motion would be identical to what it would be if released from rest. And as we have seen in the previous slide, whether or not it will slide down will depend on the angle of inclination compared to critical angle. If this angle is greater than critical angle, it will slide backwards. If not, it will remain at rest. So if tan theta is greater than coefficient of static friction, then it will have a downward acceleration given by g into sin theta minus mu k cos theta. So when it is sliding downwards, the direction of friction force will be opposite. That would be the free body diagram when it is sliding downwards. This will happen only when tan theta is greater than coefficient of static friction or angle of inclination is greater than critical angle. We can ask a further question, or we can add a further question. What is the ratio of time taken to go up vis-a-vis time taken to come down if tan theta is greater than mu s? So we know the upward direction acceleration, which is retardation. This is the acceleration in the upward direction. We also know the acceleration in the downward direction. This is the value. Since the distance is same, 1 by 2 at square will be equal. or acceleration into square of the time for upward journey and downward journey will be equal. So, in the downward direction, since the acceleration is smaller, the time taken will be larger. In other words, time taken would be inversely proportional to the square root of acceleration. Again, slight variation of a similar question. In this case, so far we have taken either no force acting the block, a force along the slope acting on the block. This time we will take a force acting perpendicular to the slope. So, here particle m of 10 kg is placed on fixed inclined plane as shown. What will its motion if no external force is acting? The first one, the simplest one. If no external force is acting, is standard question which you have seen earlier. Since tangent of angle is greater than coefficient of static friction μs, hence it will slide. So, if the block is placed on the inclined plane and released, it will have a downward motion, downward acceleration. What is the effect of force F perpendicular to the inclined plane? And what has to be the minimum value of F so that F remains at rest? These are the two questions, further question we can ask in this question. The moment you apply F perpendicular inclined plane, what is the effect? First of all, normal reaction will change, and as the normal reaction changes, the maximum frictional resistance also will change, F max will change, whereas the driving force mg sin theta will remain the same. If you look at the free body diagram, this would what the free body diagram look like. Mg cos theta, mg sin theta, normal reaction, F is acting in downward direction, and friction will act in the upward direction. So, if you have to find the third question, what has the minimum value of F so that F remains at rest? One way of answering the question would be, again it is a limiting state. Hence, the maximum frictional force has to be equal to mg sin theta driving force. But in this case, what is the maximum frictional force? Maximum frictional force will be equal to μs times normal reaction, and the maximum friction force is μs times normal reaction. And how much will be the normal reaction? That we can find out using summation of forces in y direction equal to 0. There is no motion in the y direction. Hence, n will be equal to F plus mg cos theta. We substitute these values, μs times F plus mg cos theta equal to mg sin theta. We substitute the values and solve, we find F is equal to 160 Newton. So, if we apply a force of 160 Newton, it will be in the limiting state. If you apply a force which is smaller than 160 Newton, it will have a downward acceleration. And if you apply a force greater than 160 Newton, it will still be in a state of rest, but in that case, it will be in a static state. At F is equal to 160 Newton, it is in the limiting state. That's the minimum force what we need to apply to keep it at rest. That brings us to the end of this part of video lecture. Thank you.